In example 4, we're given a few pieces of information and we want to prove these two triangles are congruent. It looks like some of them here are labeled, so we'll figure that out as we go. We're given that angle NER, which is this one, is congruent to NVR, which is this angle, and it's marked. If it wasn't marked, you'd want to absolutely make that mark in the diagram yourself. And we actually need to state that here in our proof. And that's given. RN bisects angle ERV is also given. Notice how this is a line segment that bisects an angle. It's the angle that's being cut into two congruent pieces. The definition of an angle bisector for our diagram here is simply that this angle would be congruent to that angle. RN is here, and it bisects ERV, splitting ERV, which is the whole angle, into two congruent pieces. We need to state, though, that those two angles are congruent, so we can write angle ERN is congruent to VRN. There's a couple different ways to name those angles. We totally need to have the R here, and we can't just name angle R because we don't know which one we're talking about. So we do need to list a point that's on one side that forms the angle, and then a point that's on the other, and those will go on the left and the right. And then the middle one, of course, will be the point at the vertex. So we've accurately labeled this on the diagram. We've written our statement. We're using the fact that the definition of an angle bisector splits an angle into two congruent pieces, and we're using our given information here and linking all that through. Now, if we look at this large triangle, we have two angles that are congruent. That means that the sides opposite them are also congruent. And that's the angle side theorem. The angle side theorem states that if you have two angles that are congruent to each other, then the sides opposite them are congruent. And vice versa would also work. So we are allowed to prove that ER, this line segment, is congruent to VR or RV. Either way, a couple different ways to name those line segments. We're trying to prove here that a triangle ENR is congruent to VNR. Let's see if we can do that now. We've got angle, side, angle, and that is a legitimate way to prove that two triangles are congruent. So we're good to go. We have listed our proof statement last, and we have logically proven that that is the case.